Welcome back to another physics episode on deriving equation. In the last video, I posted on deriving your third kinematics equation. In this video, I'm going to derive the last one, which is v final squared equals to initial velocity squared plus 2as. Again, if you have not tried this, try it out now before I show it to you. You will learn much more from you doing yourself than me showing it to you. If you're stuck on how to approach this part, take a look at this equation. The variable that is missing, the symbol that is missing here, is your t, is your time. So similar to last time, we're going to solve for time. Substitute that time in our new equation. Looks like my equation 1 is a lot easier to use to solve for time. So I'm going to solve for t in equation 1, then substitute into equation number 2. Very similar to the last one, but I'm going to take a few more steps in this particular derivation. Here's a good time to pause your video and try the derivation yourself before me showing you how to do it. Okie dokie, let's do this one. Let me show you how this one works. First of all, again, I'm going to solve for t in my first kinematics equation. I have v is equal to u plus at, and I'm going to solve for t. The first step I'm going to move u to the other side by subtracting both sides of the equation by u. I will be left with v minus u is equal to at. Then I'm going to divide both sides by a, which will leave me with t is equal to v minus u divided by a. Now I'm going to substitute this t, over here in my second equation. My second equation will look like this. S is equal to v plus u divided by 2, and my t will be v minus u divided by a. Okay, if I simplify this one, I will be left with S is equal to v plus u in brackets, and I'm going to put the top in brackets as well, which I have v minus u in brackets divided by 2 is on the bottom as well as a. Now here's the interesting part. So remember, you may have seen something that looks like this in math. Let's say you had x minus 2 and you had x plus 2. If you FOIL this together, if you distribute this, you would end up with x squared minus 2 squared, which in this case would be 4. Similar to our case, we can do the same thing. What we will end up is, we have v on the outside, so we'll have v squared. This one is plus u and this is minus u, so in the end we'll have minus u squared. This one we divided by 2a. We're getting closer to what we want. If we want to make our equation look like the kinematics equation, we're going to have to multiply both sides by 2a. Okay, we're going to multiply both sides by 2a. We are going to end up as a result of 2a s equal to final velocity minus initial velocity. Last but not least, we got to move initial velocity to the other side, and me forgetting the squares. Moving it to the other side, we will end up with v squared. This goes away. We have v squared is equal to, I'm moving this side of the equation to my right side, I will have 2as plus u squared. Or you can write it the other way around. Plus 2as. There we have it. We just derived our last kinematics equation. I hope this was able to confirm some of the steps you took. If you're not sure about foiling, go check back in in your previous math notes. Otherwise, hope you enjoyed this video, and I will see you next time.